There's a concept in radiation protection called ALARA, and it stands for as low as reasonably achievable. Within reason, you want to lower the levels as low as possible. That's the acceptable answer, if you will, for an acceptable limit. Now, at some point you have to set an upper limit, right? Because there's going to be times that people are exposed and you don't want them to be exposed any higher. NASA actually has their own limits. They petitioned the Environmental Protection Agency years ago to not be encumbered by the same limits you would have if you were a nuclear power plant worker, for instance. Because, first of all, your career wouldn't be very long because the limits are much lower for a nuclear power plant worker. But the second reason is their petition made the claim that being an astronaut is a hazardous occupation, and you're entering into it knowingly that it's hazardous for a variety of reasons, including potentially radiation, and there should be higher limits. And so they won this petition, and so astronaut limits are set in a different way than they are for terrestrial workers. And it's rather complicated the way they do it, but it basically has to do with allowing an astronaut to have an increased risk, and normally it's a 3% risk of a long-term fatal cancer, which is calculated, and it is they try to derive to the best of their ability through things like results from radiation biology experiments and all kinds of bodies of evidence. And then they set the limits based on the astronaut's age at first exposure, and then whether they're a male or female, because male and female have different response to certain types of radiation.